Okay, this is the Module 15, Part 3 notes, hypothesis testing for means, page 1, reminder. So mu sub x bar, the mean of all the sample means, is the same as the population mean. Sigma sub x bar is our population standard deviation divided by the square root of the sample size. Okay? So our central limit theorem for means, we want to know that our sample is larger than 30 or the population's known to be normally distributed. Then we're using a z-score. We use a t-distribution though and a t-score if we don't know the population standard deviation, so we don't have sigma, or if our sample size is not large enough. And then we're going to go back to the student t-distribution like we did with confidence intervals. Okay. So here is how we are finding our t data value. We are going to take our sample mean, our x bar. We're going to subtract our population mean, our mu, and we're going to divide by the sample standard deviation divided by the size of the sample. So just a reminder here, x bar is our sample mean. Mu is our population mean. S is our sample standard deviation. And n is our sample size. Just a reminder that we need to calculate the degree of freedom. We're going to need to enter that value in when we use Excel to find these. Okay, so properties of the t-distribution, a reminder. T-distribution changes depending on the degrees of freedom. Centered at and symmetric about 0. Area under the curve is 1, so consistent with our normal distributions. As the sample size increases, the t-distribution gets closer and closer to the normal distribution. Okay. And so we can use the t-distribution and the critical value method or the p-value method. I will tell you when it comes to using the t-distribution, I do all of the examples using the critical value method because that just makes a little more sense to me.